Good day, ladies and gents. So today we're going to continue Unit 6, Similarity, and we are going to be talking about the triangle similarity. So AA similarity, SSS similarity, and SAS similarity. So if you look on page 1, a couple things to know is for similar polygons, anything similar, you got to remember that corresponding angles are congruent and corresponding sides are proportional. So that's very important to remember. So if we go all the way down to the bottom here is what we need to focus on. So step 1, so these are the givens and stuff like that, but this is what we want to focus on: the AA similarity, SSS similarity, SAS similarity. So every time I say A, I'm talking about angles, and those angles are supposed to be congruent. Every time I say side, that we know that the sides are proportional. So remember that. So you need to recognize that we're going to be saying this both ways. We might be saying correspondings are proportional, corresponding angles are congruent, or we might just switch those and say corresponding angles are congruent. So it's just the order of the sentences. The congruent still stays with angles, proportional stays with sides. So it could look like this, or it could look like this, saying angles first. So just remember that corresponding angles. Angles goes with congruent because you like to have AC, right? It's Florida. It gets hot. So we want angles congruent, sides proportional. All right. And notice angles are congruent, sides proportional. We just said the angles second time. All right. So AA similarity, SSS similarity, and SAS similarity. All right, so we are on page 21. Go to page 21, and we are going to be talking about these three and what they look like. Okay, so there's only 3 of these. So we've seen stuff like this before when we're talking about triangle congruency, but now we're talking about triangle similarity. When we were talking about triangle congruency, so triangle congruency, so there's congruent and non-congruent. So you remember those. So that was, everyone always remembers the 2 bad ones, AAA and ASS or SAA. Okay, and every other combination of A and S is good. Side, 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 angle, side, angle, AAS or SAA. So just a little more for you. Okay, and then hypotenuse leg. Okay, and then we might go a step further and go CPCTC. All right, so you remember this idea, but now for triangle similarity, there is AA similarity, which is actually the same thing as AAA. The same thing as AA. There's SSS similarity and SAS similarity. So it's the same idea, but this time around, you got to remember that corresponding angles are congruent and corresponding sides are proportional. All right, so corresponding angles are congruent, corresponding sides are proportional. All right, so now that we have that down, let's actually do some examples. Let's figure out what we're talking about first of all. All right, so AA similarity. So that means that 2 angles on one triangle need to be congruent to 2 angles on the other triangle. So 2 corresponding angles are congruent. All right, so AA similarity. All right, so when you have these angles, the first thing you should really do is actually find all 3 angles. So just because these 2 angles, so we know that this angle right here is equal to this angle right here. That's excellent. So we have, but this 74 does not equal this 31. Well, maybe it's our missing angle. So I'm just going to show a little bit extra work. I know that 75 plus 74 plus our angle C is equal to 180. So we need to solve, right? So if we take 180 and we subtract that 75 and that 74, what would angle C have to be? It would have to be 31. And we didn't look over at this other triangle because this triangle may not have anything to do with this. We don't know yet. Okay, so this is 31. Okay, do the same thing to the other part. 75, 31, and that angle E would also equal 180 degrees. So 180, subtract the 75 and the 31 in your calculator, and we would be left with E is equal to 74. Okay, so now let's see what works. Okay, so on this triangle, I know that angle A is equal to the other triangle, angle D. So this angle A on this triangle is equal to angle D on the other triangle. And do I have another one? Yes. So I'm going to put two little angles on there. 74 is equal to this 74. So angle B is equal to angle E. Okay, and we can actually go a step further. We have everything we need. So we have this angle. So these angles are congruent and these angles are congruent. But we can actually go a step further and say 1, 2, 3, 1, 2, 3. Angle C is equal to angle F here. All we needed was 2, but we were able to actually do all of them. So yes, this is similar. The reason why was AA similarity. And now let's actually figure out what it is. So if I had given you triangle ABC, what would be that similar to that? Not congruent, similar. What would be similar? That would be triangle. So what matches up with those letters? A would match up with D. B would match up with E. And C would match up with F. And that would have been your answer. All right, so let's do another example. Number 2. All right, number 2. Now, did they give us anything about sides? No, so we're probably going to try AA similarity. They didn't say anything about sides, so we're probably going to do AA similarity. So we just need to find 2 sets of angles that are congruent. All right, so at this moment, so remember, all you have to do is start with your givens and work off of your givens. So as of so far, all we have is angle V is equal to angle Y. That's all we have so far. We need something else. So that's all we have so far. So we did everything off of our givens. Now we're going to try vertical. So that means if you have lines that crisscross, these 2 angles would be equal, or these 2 angles would be equal. Wait a minute, these are vertical, those are horizontal. Why? Well, because if I turn my paper, oh, now they're vertical. So that's what it works. Okay, so we're going to try vertical. Let's see if that works. Okay, do we have any vertical angles? Yeah, right here. This angle X be equal to this angle X. So angle, and now I really should call it WXV, but we're just going to take the time and just say angle X is equal to angle X. Angle X here is equal to angle X here. Why? Because they're vertical. Okay. And then we could go further and say that these 2 angles are equal because they are the third angle theorem. That if these 2 are equal and these 2 are, or if these 2 are equal to that, then the third angle would have the same leftover. But we're basically done. Okay, so now we have 2 angles are equal. So that would be yes, AA similarity. And so what if I said triangle WXV? That would be similar to what? Okay, so you would say triangle. Okay, what would W match up with? Z. What would X match up with? X. And what would V match up with? Y. And that would have been your answer. All right. Okay, let's go to the next one. SSS similarity. Okay, so that means that all you would set the proportion for the sides and set them so are the sides all proportional? So corresponding sides are proportional. Okay, so we would need all 3 sides because 1, 2, 3. So let's do all 3 sides. Okay, the best thing you can do for this is write let's write it up here. Right sides from least to greatest. And I just like to always do that. That just helps me out. All right, so right here we have all three sides. We have all three sides. Okay, so the best thing you can do, because they can rotate and all this stuff. All right, so we are going to write the sides from least to greatest. Okay, so these numbers from least to greatest, 3, 4, and 5, all over. So we did the first triangle, 3, 4, 5. Now match it up to the other one. From least to greatest will be the side lengths, 6, 8, and 10. So what I'm saying is, if this is correctly proportional, then the smallest side, when you either enlarge it or reduce it, if you make it bigger or smaller, so the 3 was the smaller side on this triangle, whatever it blows up to be would still be the smallest side on the other triangle. So 3 would definitely still go with 6 because it's smallest side over here. It would still be the smallest side over here. Okay, so the question is, are those equal to each other? Are the proportions equal? So that's the question. So you can divide this just to be a decimal if you do not care about the scale factor. So 3 divided by 6 is 0.5, 4 divided by 8 is 0.5, and 5 divided by 10 is 0.5. So that checks out. So these are all proportional. Okay, so yes, because of side, side, side similarity. So the little squiggly, remember that? That means similar. Not SSS, it's SSS similarity. And what if I said triangle, let's say PQR, PQR. Okay, so if I go PQR, and that's it, that's all I did. I didn't go back home, I just went PQR. Okay, so what was that? I went 3, then 5. So if I did 3, then 5, oops, sorry. If I did 3, then 5, so 3, then 5, that's like going 6 and 10. So if I go 6, then 10, so 3, then 5, that's like me going 6 and 10, so that would be STU. So that's similar to triangle, STU. And that would be our answer. All right, sweet. Okay, let's keep going. All right, number 4. Okay, so all they did was give us all 3 sides, so we're probably going to use side, side, side similarity. All right, so write these from least to greatest. Okay, so if I go from least to greatest, that would be 30, 32, and 35. And that would be over, okay, from least to greatest. That would be 24, 25, and 28. So the question is, are those equal? Are the proportions equal? Meaning, are they proportional? All right, so let's check. So if we do 30 divided by 24, that'd be 1.25. 32 divided by 25, that would be 1.28. And then 35 divided by 28, that'd be 1.25. Okay, now hold on a second. Does that feel right? No, look at this. They had different decimals. Okay, let's double check. Did I actually write down the numbers correctly? Because maybe I just did a typo. So let's see. 30, yep. 32, yep. 35, yep. All right, 24, 25, 28. All right, check in your calculator. 32 divided by 25. Yeah, I did this correctly. So were these equal? No. So this is not similar. No, not similar. Oh, those tricky little buggers, right? Okay, so that one did not work. That did not work. Okay, and finally, the SAS. Okay, so what we're saying is these two sides would have to be proportional, where this angle right here would have to be congruent. Now here's the important part. The S's have to be here, and then the angle has to be here. So we're looking at these two sides and this angle right here in the middle, and then so where it hinges. like where those two sides meet, that angle has to be equal. That's what's going on right now. Okay, so if two corresponding sides are proportional and the included angle is congruent. So included meaning where they met, where the two sides met. So this, this, and this. Okay, so let's give this a try. So, and remember, using the bottom of page 1, that really helps out. Because remember, reflexive property, we're used to the reflexive property looking like this. Because so these two sides are shared, so that it's the same size, so they equal. That's the reflexive property. But the other way the reflexive property could look, is that when you have two triangles like this, then the big triangle angle right here would be the same as the little triangle angle right here. They are the same angle, so that's the other way the reflexive property could look. All right, so here we go. So on this one, they only gave us two sides, right? So we're probably going to be using the one with two sides, SAS. So they gave us two sides and one angle. So where those two met, where these two met, equal that? Yes, it does. So we have angle K is equal to angle N so far. That's perfect. So now we have to look at the two sides that they hinge at. So once again, go from least to greatest. So least to greatest, so in this triangle would be 8 and 20 over from least to greatest 6 and 15. So the question is, are those two equal? We'll put it in your calculator. 8 divided by 6, we get 1.3 repeating forever and ever and ever. And then 20 divided by 15, yes, we also get 1.33333 repeating forever and ever and ever. So that checks out. Okay, sweet. So we know that yes, these are similar because of SAS similarity. The middle angle is congruent, and the two sides that hinge out of it, so the included angle is equal, and the two sides are proportional. Excellent. So now, what if I said triangle JLK? That would be similar to what? Okay, so if I went JLK, so that would be the nothing side and then the 20. So if I did nothing, then 20, so nothing, then 20, that would be the nothing and the 15. So nothing and 15. And so that'd be MPN. So triangle MPN. And that's what we'll match up with. All right, sweet. And this one right here. Okay, so right now all we have we're missing the third side, so it's probably SAS similarity. That's probably what we're going to do. Okay, so so what I suggest that you might want to do is maybe separate the two triangles. That might make your life a little easier. So let's go ahead and do that. So the smaller triangles, pretty easy to see. So A, D, and E. So this A to D is still 15. A to E is 12. And then the bigger triangle, okay, A, B, C. Okay, so A to B, all of that is 25. A to C, all that was 21. Okay, and here's the important part. When you drew the two triangles, they both had angle A right there. So this angle right here would be equal to this angle right here. And it's kind of hard to see that, so if I turn it this way, you might be able to see it better. So if you look, so you see how you have a triangle right there, they would share the top angle. So here we go, they would share this top angle. All right. Okay, so now, and then on either side of that angle are the two sides. So yes, this works out so far. Okay, so we know that angle A on this little triangle is equal to angle A on the other triangle. And so now we just have to see if the sides are proportional. So I always like to do smallest to greatest, so 12 and 15 over, okay, smallest to greatest, 21 and 25. Okay, the question is, are those equal? All right, so in our calculator, 12 divided by 21, we get 0.5714, and it keeps going. All right, and 15 divided by 25, we get 0.6. Uh-oh. Are those proportional? No, that did not work out. So no, this is not similar. And what was broken? What broke of the two rules? What was broken? Was it the sides being proportional, or was it the angles being congruent? What was broken? It was the sides. So why was this not good? Because corresponding sides was not proportional. So, but we can just say not similar. But it's nice to know why. What was broken? The sides. The sides broke it. The angles were still good. The sides is what broke it. All right, excellent. Great job, guys. Okay, so the best way to do this is actually do some more practice problems. So we're going to be going to page 22. All right, so we are on page 22. Let's keep going. All right, so on page 22, let's do some examples here. All right, so on page 22. Okay, so are there any sides here? There are no, so we have AA similarity, SAS similarity, and SSS similarity. Those are 3 types. Okay, so think about how many sides they gave us. If they didn't give us any sides, it's pretty easy to say that we're going to try AA similarity. So they didn't give us any sides, so we're probably going to try AA similarity. All right, so now you see how they have parallel sides right here. So I'll just darken this. There's these arrows right here. See those arrows? So I'm just going to darken just a little bit. So there's an arrow here. There's an arrow here. That means that they are parallel to each other. I've taught you to always turn your paper until those parallel lines are horizontal. So we can do the alternate interior angles, the Z. So we do the Z. I know that this angle is equal to this angle. So that's angle C is equal to angle G so far. Angle C is equal to angle G. All right, what else? If I do the Z the other way, the backwards Z, I know that angle D is equal to angle F. And then I have enough information so far, but I can actually go a step further and say 1, 2, 3, 1, 2, 3. So this was because of alternate interior. This was because of alternate interior. And then I know that angle E is equal to angle E on the other one because of vertical angles. Okay, so AA similarity is the same thing as AAA, so I can actually prove all 3. Okay, so then now that we have that, I know that yes, these are similar because of AA similarity. Okay, so what if I said triangle DCE? Okay, would be similar to what? Okay, so if I said DCE, now how did I do that? Okay, so D was a double. So what does D match up with? It matched up with the other double, F. So triangle F. C was a single. What matched up with C? Another single. That was G. And E was a triple. What was the other triple? E. All right, sweet. All right, let's go to number 2. All right, so on number 2, okay, I know it's kind of hard to see, but this is a 90-degree angle, and this is 39. And this is a 90-degree angle, and this is 51. Just darkening that a little bit. Okay, so we have those. Okay, now I know for a fact that this is 90 degrees. So we need to figure out what the missing angle is. So if we put this in the calculator, 180 minus 90 minus 39, I'd be left with 51. So that had nothing to do with the other triangle. So I know that these 3 angles add up to 180 degrees. Oh, look, 90 again, 51, what's left over? Oh, 39. Okay, so now we have to see, so there's no sides here, so we're going to try angles. So what is equal to each other? All right, so I know for a fact that angle Y on this triangle is equal to angle C on this triangle. Excellent. Okay, what else we got? I know angle E is 39. I have also an angle E, a 39 on this side, which is angle H. And this triangle, angle S, would be equal to angle W, because this is 90, this is 39, and this is 51. So that works out. Okay, so yes, these are similar because of AA similarity. And what if I said triangle? What if I said YSE? Or let's do YES, because yes. So if I said YES, will that be similar to, not equal, similar? That would be similar to triangle. Okay, so if I said YES, I went 90, 39, 51. So do the same pattern. So Y matched up with C, E matched up with H, and S matched up with W. And that would be your answer. Excellent. Okay, so number 3. All right, let's keep going. Okay, so same idea here. You're just gonna, so 68 and 54, we'd have 58 left over. 63 and 68, we would have 49 left over. Okay, so as of so far, I know that the 68 and 68 are equal, but that's all I have. There's nothing else. So this is not similar. And what was broken? Was it the sides or was it the angles? So if you look at your list, so either the sides need to be proportional or the angles have to be congruent. And what was broken? The angles. So corresponding angles, not congruent. So that was the rule that was broken. Okay, and number 4. Okay, so this one, they said that angle P is equal to angle Z. Excellent. So angle P is equal to angle Z. Do I have another one? So that was given, but then what else can I try? So we would do our givens. There's no parallel line, so we can't use that. So our other fallback is vertical. And so, there's vertical. So X is equal to X. Okay, so yes, this is similar because of AA similarity. So let's say I said triangle PXQ, that would be similar to what? So if I said P, X, then Q, I went single, double, nothing. So do the same thing on the other one. Single, double, nothing would be Z, X, Y. So right there, that's number 4. Excellent. All right, let's go ahead and go to number 5. Okay, so they gave us 3 sets of sides. So I know for a fact that we have vertical angles as well, but because they gave us 3 sides, we're going to try SSS. SSS similarity. Got to say that. Okay, so this is really simple. Just put the numbers from least to greatest. So we have, on this triangle, we have 5. This is, I know you're having a little trouble seeing that, but that is 12. And that says 43.2. Okay, you should be able to see everything now. So we have 5, 12, and 15. And on this other triangle, we have 18, 43.2, and 54. So the question is, are those equal to each other? So let's check. So put it in your calculator. So 5 divided by 18, I get 0.277777. 12 divided by 43.2, I get 0.277777. And 15 divided by 54, 0.277777. Okay, so all those work. So yes, this works out. So yes, it's because of SSS similarity, because side, side, side. All right, so what if I said triangle? Let's say PAR. PAR. Okay, so if I go PAR, I went 12, then 15. I went 12, and then 15. So if I go 12 and 15, that would be the same thing as 43 and 54. 43 and 54, and that would be YTR. So that's similar to triangle YTR. Fantastico. All right, number 6. Okay, we're just breezing right on through this. All right, I know this is kind of hard to see, but this is 15. This is 6. This is 8. That's 56. That's 40, and that's 20. All right. Okay, so I highly suggest that you separate the two triangles. That'll make your life a little easier. So separating the two triangles, I know that this is W, and this is X, and this is V, where this is 20 and 15. Now, you see how it's kind of hard to see? I highly suggest that you circle the corners, and then the numbers pop out a little better. Okay, so now let's do the other triangle, so the bigger triangle. All right, and that goes W, Y, U. All right, now what's this entire distance? 15 and 6 all together make 21. So we added those two numbers together. And all this side, 20 and 8 make 28. All right. Okay, awesome. And you remember that when you have a triangle like this, that this angle, so angle W on this triangle would equal angle W on this other triangle. Okay, excellent. So we were given two sides, and we have an included angle. So the angle is where those two sides met up, so it's probably going to be SAS. Oh, but wait, they gave us this 40 as well, and this 56. Now, I know you want to try SAS similarity. I know that, but don't. Because they gave you three sides, you're going to have to use all three sides. So let's try it. So we have 15, 20, and 40. Write them from least to greatest. And we would have 21, 28, and 56. So the question is, are all those equal? Okay, so 15 divided by 21 is 0.714. 20 divided by 28, 0.714. 40 divided by 56, 0.714. So this checks out. Excellent. So yes, this is similar because of side-side-side similarity, not SAS. Because they gave us three sides, we have to use all three sides. Okay, and then what if I said triangle? What if I said WXV? That'd be similar to what? All right, so if we went WXV, so if I went WXV, so that would have been 15 and then 40, so 15, then 40. So if I go 15 and 40, that matches up with 21 and 56. So 21 and 56, WYU. So triangle WYU. All right. We're getting done. We're almost there. I know we're doing a bunch of problems here, but the more the merrier, right? Okay, so on this one, remember, once again, I highly suggest that you separate the two triangles. That makes your life a lot easier. So if we separate these two triangles, so let's see, the little one, okay, this right here, I know it's kind of hard to see, but that was A. So this is A, C, and B. And that would be 6, 9, and 8. And I'm going to circle the corners so the numbers pop out a little better. All right, now let's focus on the big one. Okay, so A to E, all that was 16. This was 24. And to D to A, all this. Okay, so 12 and 8, all that would make 20. All right. Okay, so now, and I totally agree with you that the angle right here, so angle A on this triangle equals angle A on this triangle. I know you want to use SAS similarity, but we can't because they gave us all three sides. We have to try to use all three sides. Okay, so least to greatest. So 6, 8, and 9. So least to greatest, 16, 20, and 24. Okay, so let's see. So 6 divided by 16, we get 0.375. 8 divided by 20, we get 0.4. And 9 divided by 24, we get 0.375. Oh, look at that. So you would double check your work, but this is correct. And look at that. This is not equal. So that was the question. Were the proportions equal? And they are not. So this is not similar. Not similar. And what was broken? Was it the angles? No, it was the sides. This side was not proportional. So corresponding sides, not proportional. That was what was broken. Corresponding sides were not proportional. All right, number 8. Okay, so that says 12, 5, and this is 16. I know it looks like a 10, but that's 16, so let's fix that. And this is angle D, that's 10, 7, and 3. Okay, so write the numbers from least to greatest. We have 5, 5, 12, and 16. And let's compare it to the other one, which is 3, 7, and 10. All right, when you divide that, you get 1.666666 repeating forever and ever and ever. You get 12 divided by 7 is 1.714. And then 16 divided by 10, we get 1.6. 1.6666 is not the same thing as 1.6, so none of these worked out. So once again, this is not similar. And what was broken? The corresponding sides. Corresponding sides was not proportional. That was what was broken. All right, 4 more problems, and then we'll be done. All right, you guys are doing great. Just stick with it. Okay, so on this one right here, how many sides did they give us? They gave us 2 sides. So this 2 sides on this triangle, 2 sides on this triangle. So we're probably going to be using SAS similarity. Okay, so we want to know where the 2 sides met. Does this angle right here equal where these 2 sides met? This right here. Are those 2 equal? Yes, because they are vertical angles to each other. So this works out. So angle E is equal to angle E here. So yes. Okay, so at this moment, angle E on one triangle is equal to angle E on the other triangle. Good, very nice. So now we just have to check the sides. So I'm going to write the sides from least to greatest, 24 and 48, over from least to greatest, 6 and 12. So 24 divided by 6, we get 4, and 48 divided by 12, we also get 4. So yes, this checks out as well. So yes, this is similar because of SAS similarity. And so what if I said triangle E? So if I said EFG, that'd be similar to triangle what? Okay, if I went E, F, and G, what did I do? I did 24, then nothing. So 24, then nothing, that would be the same thing as 6 and nothing. So 6 and nothing, that would be ERS. And there's your answer. All right, number 10. Okay, so on number 10, just in case you're having trouble seeing what that says, this was 50. This is 45. This is 31.5. And this is 35. Okay, so once again, we only given 2 sides, so we're probably using SAS similarity. So where the 2 sides met, does angle G equal to where these 2 sides met? Angle H? Yes, they do, because it was given to us. Excellent. So angle G is equal to angle H, which is what we needed. And then we check the sides. So from least to greatest, 45 and 50 would match up with 31.5 and 35. So the question is, are those proportions good? 45 divided by 31.5, we get 1.428, and it keeps going. 50 divided by 35, we get 1.428, and it keeps going. So yes, this checks out very nicely. Okay, so that works out as well. Okay, so yes, this is similar because of SAS similarity. And so what if I said triangle GEF? All right, so if I went GEF, GEF. So in this case, I went 45, then nothing. So 45, then nothing. That would be, so 45 nothing would be 31.5 and nothing. 31.5 and nothing. So that'd be HJK. HJK. J, K. Whoops. Only helps if you can see it. All right, so there you go. There's your answer. All right, 2 more problems and we're done. All right, okay, so number 11. All right, just in case you can't read that, this is 44, and that's 40. This is 27.5, and that's 25. All right. Okay, so we're only given 2 sides. Now here's the question. Where those 2 sides met, are they equal? So where these 2 sides met would be here, and where these 2 sides met would be here. Is there any proof that J is equal to Y? There's no proof of this. There's no proof that J is equal to Y. There's no proof of that. So I'm not even taking the time to check the sides because we don't know if these 2 angles are equal. I know that F is equal to F, but that's not the included angle. So this is not similar, and it's because of the angles, but there's just no proof, so we can just say not enough info. So this is not similar. Not enough info would be the better. Not enough info. So that we don't have any proof that J is equal to F. So there's no proof of that. Sorry, J is equal to Y. There's no proof. Does angle J equal angle Y? We don't know. We have no proof. No proof. So that's why we just were not sure. All right, and the last problem. Woohoo! One more. Let's do it. All right, so when we have triangles like this, we should separate them. So the little triangle, W, R, and Q. This is 15 and this is 14. And by circling the corners, I have a better chance of seeing the numbers. They pop out a little more. Okay, and then the big triangle. All right, so S, W, and Z. So this entire, so 30 and 15, they make 45. And 14 and 28. So 14 plus 28, we pop out with 42. Okay, so the question is, oh yeah, so when we separate them, I know that so angle W is equal to angle W. Now where these 2 angles met is at angle W, and 2 sides. Where these 2 sides met is angle W, and where these 2 sides met is angle W. Are those equal? Yes, it is, because of reflexive property. So angle W is equal to angle W, yes. And now let's check the sides. So if I go from least to greatest, 14 and 15, over least to greatest, 42 and 45. All right, so let's divide those. 14 divided by 42, we get 0.3 repeating forever and ever and ever and ever. And 15 divided by 45, we get 0.3 repeating forever and ever and ever and ever and ever. So that checks out as well. Okay, so yes, this worked out, SAS similarity. So if I said triangle, let's say I said QWR, QWR. All right, if I go QWR, I went 15, then 14. So 15 first, then 14. If I go 15 and 14, that's the same thing as 45 and 42. 45 and 42. So 45, then 42, that'd be SWZ. So that's similar to triangle, S, W, and Z. And that's your final answer. And you guys have a great and wonderful day.